let's take a look at number 17 from section 4.5. We want to find all complex zeros of this polynomial, and we want to write the polynomial in completely factored form. Find the complex roots, and we want to repeat any zeros if the multiplicity is greater than 1. N is 5, so a sub n is a sub 5. That's the coefficient of x to the 5th. That's 12. My constant a sub 0 is negative 25. A sub 0 over an is negative 25 over 12. That cannot be reduced. So I get, that's my p over q. And the factors of negative 25 are plus or minus 1, plus or minus 5, plus or minus 25. And the factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So this is going to give us many possibilities, actually, for the rational zeros of this polynomial. So we're going to take each number in the numerator and put it over the denominator. So that will give us a plus or minus 1 over 1, which is plus or minus 1, plus or minus 1 over 2, plus or minus 1/3, plus or minus 1/4, plus or minus 1/6, plus or minus 1/12. We're also going to get plus or minus 5, plus or minus 5/2, plus or minus 5/3, plus or minus 5/4, plus or minus 5/6, plus or minus 5/12. And then when we put the 25 over all of the possible denominators, we get plus or minus 25, plus or minus 25 over 2, plus or minus 25 over 3, plus or minus 25 over 4, plus or minus 25 over 6, plus or minus 25 over 12. So notice this gives us 36 possibilities. We get 6 positive possibilities in each row, 6 negative possibilities in each row, so that's 12 possibilities for each row, and we have 3 rows altogether. Now for a problem like this, you want to use my math lab. That's a technology, or you could use your graphing calculator. That's a technology that's available to you. Plot is one of the functions. I'm going to graph this polynomial function. And what I'm going to do is I'm going to figure out how to actually position this graph in the xy plane. In other words, what are the smallest and largest x values that I really want? And since my smallest possible root is negative 25 and the largest is positive 25, I'm going to go from negative 25 to 25 with my x values. And I'm going to just graph it. And I see that when I graph this, I'm really zoomed out. My y's are going from negative 60 million to positive 40 million. So I'm going to put a range on my y's by giving it a range on plot, a range of values for plot range. I'm going to go from negative 10 to 10. I can see that's not enough because I'm not seeing the whole graph. So if I go from negative 100 to 100, that's a lot better. But I see that I can scale down the y values even more. Because I can see that I do have some zeros here. I have 2 zeros that I'm seeing. Those are x-intercepts. Zeros are the same as x-intercepts. So I'm going to change the range on my y values from negative 50, given what I'm seeing on the graph, to 1. And I can see that that's really much better. And what I'm going to do is I'm going to change the range on my x, and I can see these zeros occur between negative 2 and 2. And this allows me to see that I've got a 0 between negative 1 and 0 and between 1 and 2. And I can actually zoom in even closer, but I've got a negative 0 between negative 1 and 0, and a positive, and I see that one has an even multiplicity because the graph only touches at that 0 between negative 1 and 0. The 0 between 1 and 2 has an odd multiplicity. So, I'm going to check using synthetic division. I'm going to get more information here. So let's check. Let's look at our possibilities. Let's check 1/2 as a 0 using synthetic division. Here are the coefficients of my polynomial. You would want to make sure this is a 5th degree polynomial, so you need 6 coefficients. And if any power of x was missing, you would make that coefficient 0. So like if I didn't have an x to the 4th term, I would write a 0 where the negative 56 is. I bring down the 12, multiply by 1/2, and I get 6. Add that to negative 56, I get negative 50 times 1/2, negative 25, and I multiply that by 1/2, I get a positive. When I add that, I get 50 times 1/2 is 25. Adding gives me 48. Half of 48 is 24. Adding that to negative 65, I get negative 41. Multiply negative 41 by 1/2, I get negative 20.5. And that gives me negative 45.5 when I add. That remainder is not 0. So 1/2 is not a 0. And I knew that from looking at the graph. So I wasted my time checking that because I knew the 0 was between 0 and negative 1. So I shouldn't have checked 1/2. That was a waste of time. I am going to check negative 1/2 though, because that actually looks like the 0. And bring down the 12, multiply by negative 1/2 to get negative 6. Add it to negative 56, I get negative 62. Multiply that by negative 1/2, I get positive 31. When I add, I get positive 106. Half of that times negative 1 is negative 53. Add that to 23, I get negative 30. Negative 1/2 times negative 30 is 15. I get negative 50. That times negative 1/2 is 25. The remainder is 0. So negative 1/2 is a 0. So I know the multiplicity is even. So the multiplicity, since this is a 5th degree polynomial, is either 2 or 4. So I am going to notice, because the graph touched at negative 1/2 and it didn't cross, the multiplicity is even. So I'm going to check negative 1/2 again, but now I'm going to use the coefficients of my quotient. 12, negative 62, 106, negative 30, and negative 50. Bring down the 12, multiply by negative 1/2, add that to negative 62, and I get negative 68. Half of that is 30, negative 1/2 times that is 34. Add that to 106, I get 140. Half of negative 1/2 times 140 is negative 70. And notice when I complete the process, I get 0 as a remainder. So negative 1/2 is a 0, and the multiplicity is 2 or 4. So I'm going to use these coefficients of this quotient to check negative 1/2 again. If I get a 0 remainder, then I know that the multiplicity has to be 4. It has to be even, and it has to be an even positive integer less than 5. So let's repeat the process. Negative 1/2 times 12 is negative 6, plus negative 68 is negative 64. When I multiply, negative 74, when I multiply that by negative 1/2, I get 37. When I add that, I get 177. I don't even need to keep going. I know when I multiply 177 by negative 1/2, I'm not going to get positive 100. So I'm not going to get a remainder 0. So that means negative 1/2 is the 0 multiplicity 2. So I couldn't get a remainder of 0 the third time. So there's no way I'm going to get a remainder of 0 the fourth time. All right. So notice that I'm going to do another check. This 0 has to be between 1 and 2. When I look at my possibilities of a 0 between 1 and 2, and I can see that possibly could be 5/3. So I'm going to check 5/3. And I'm going to use the coefficients of the last quotient that I got where my remainder was 0. So I bring down the 12. 12 times 5/3 is 20. When I add that to negative 68, I get negative 48. When I multiply that by 5/3, I get negative 80. Adding that to 140 gives me 60. 5/3 times 60 is positive 100. And this remainder is 0. That tells me 5/3 is a 0. And the multiplicity is 1. And if it's not, I'll find that out. But I'm pretty sure, I know it's an odd multiplicity because when I looked at the graph crossed at that 0. So what this tells me is when I factor f of x, I can write it as 12 times x minus a negative 1/2, which is x plus 1/2. And I get 2 of those since that multiplicity was 2. And I'm going to get an x minus 5/3 here. And then I'm going to get an ax squared plus bx plus c. Since this is a 5th degree polynomial, this has to be a 2nd degree polynomial here. So what I'm going to do is I'm going to multiply x plus 1/2 times x plus 1/2, which is the square of x plus 1/2. And you'll recall that when I square an a plus b, remember that means a plus b times a plus b, that's a special form that always multiplies, if I use the distributive property twice, also known as FOIL, I get a squared plus 2ab plus b squared. In this case, my a is x, my b is 1/2. So this is x squared plus 2 times x times 1/2 plus the square of 1/2. 2 times x times 1/2 is simply x. The square of 1/2 is 1/4. All right, now I actually want to also multiply this result by x minus 5/3. So x minus 5/3 is going to get multiplied by my x squared plus x plus 1/4. So when I multiply x times x squared plus x plus 1/4, I get x cubed plus x squared plus 1/4 x. When I multiply negative 5/3 times that second polynomial, I get negative 5/3 x squared minus 5/3 x minus 5/12. So I need to combine my like terms. I need to write x squared as 3 over 3x squared, since I'm combining that with a negative 5/3 x squared. I need to write (1/4) x as 3/12 x, and negative 5/3 x as negative 20 over 12 x. And I'll combine the like terms, and I get x cubed minus 2/3 x squared minus 17 over 12x minus 5/12. All right, so I'm going to use long division, and I'm going to divide this into my polynomial. And the result is going to be my second degree polynomial. So I write my divisor, which is the product I just obtained, and I divide that into 12x to the 5th minus 56x to the 4th plus 75x cubed plus 23x squared minus 65x minus 25. And x cubed goes into 12x to the 5th, 12x squared times. And when I multiply that 12x squared by every term of my divisor, I get 12x to the 5th minus 8x to the 4th minus 17x cubed minus 5. And I am going to subtract. I can turn this into an addition by changing the sign of every term involved in the subtraction. So the first addition always gives 0. The second gives negative 48x to the 4th. The third addition gives 92x cubed. And the fourth addition gives me 28x squared. I'm going to bring down the negative 65x. Since my divisor has 4 terms, I need 4 terms before I repeat this process. So x cubed into negative 48x to the 4th is negative 48x. When I multiply every term of the divisor by negative 48x, I get negative 48x to the 4th plus 32x cubed plus 68x squared plus 20x, and I subtract. I can turn that into an addition by changing every sign of what I was subtracting to its opposite. And now I'm adding, and the first addition is 0, of course. 92 plus a negative 32 gives me a positive 60, and the coefficient, this is the coefficient of x cubed. 28x squared minus or plus a negative 68x squared is negative 48x squared. Negative 65x minus 20x is minus 85x. I bring down the minus 25. When I divide x cubed into 60x cubed, I get a positive 60. When I multiply positive 60 by each term of the divisor, I get 60x cubed minus 40x squared minus 85x minus 25. And when I subtract this from itself, the result is 0. So I take this quotient, 12 x squared minus 48x plus 60, and I factor out a 12. And I get 12 times x squared minus 4x plus 5. So my polynomial factors into 12, so I'm moving that 12 out in the front, times the factor x plus 1/2, times another x plus 1/2, times x minus 5/3, times the factor x squared minus 4x plus 5. To find the zeros of x squared minus 4x plus 5, I'm going to solve x squared minus 4x plus 5 equals 0. A here is 1, B is 4, C is 5. And I'm going to use the quadratic formula, which told me my x would be minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 4 plus or minus the square of negative 4 minus 4 times 1 times 5, and that's all over 2 times 1. So my x is 4 plus or minus the square root of 16 minus 20 all over 2, which is 4 plus or minus the square root of negative 4 over 2, which is 4 plus or minus the square root of 4 times the square root of negative 1 all over 2, which is plus or minus 4 plus, which is 4 plus or minus 2i. Square root of negative 1 is I. I divide the 4 and the 2i by 2, and I get x is 2 plus or minus I. So those are the other two zeros. So what are my zeros? My zeros are negative 1/2, negative 1/2, 5/3, 2 minus I, and 2 plus I. So that's what I would type in for the x's that are my zeros. Now I can do my factorization. I can do the second part of the problem. F of x is 12 times x plus 1/2 times x plus 1/2 times x minus 5/3 times x minus the quantity 2 minus I times x minus the quantity 2 plus I. Let's distribute those minus signs so we don't have double parentheses. So I'll recopy the first 4 factors, and then these last 2 factors become x minus 2 plus I, x minus 2 minus I. And that is the factorization. That's how you would do that problem.